Nucleophilic substitution of halogen alkanes is when we use a nucleophile. Nucleophiles are those species that have pair of electrons to donate. For example, cyanide is a nucleophile because we have one lone pair of electrons on nitrogen. And also nucleophiles could also be, they could have strength, like cyanide is stronger than hydroxide, which is a nucleophile. In terms, hydroxide is stronger than ammonia, which has a lone pair of electrons to donate. And finally, water is also another nucleophile. Nucleophiles are also known as ligands, if you remember them back in the days. They're also Lewis bases. Now, when we look at a halogen alkane, if you are a primary halogen alkane, you should know by now primary means the carbon attached to the halogen has two other hydrogens. The carbon is slightly electropositive, the bromine is electronegative. The lone pair of hydroxide are going to be attracted to the positive carbon and they form a primary alcohol. Bromide is released. This is primarily substitution nucleophilic. 2 means bimolecular. That means both reactants, the hydroxide, the nucleophile, and your halogen alkanes are part of your rate determining step. So the 2 in SN2 is because it's bimolecular, and then SN2 is only good for primary halogen alkanes. If you are a tertiary halogen alkane, those are carbons that have 3 other alkyl groups, and then halogen. The story is the same as before. There will be nucleophilic substitution of this halogen. In this case, I put cyanide, which the lone pair of nitrogen will come and attach itself to this to give you a nitrile. So you have CN at your ending and bromide is released. This primarily goes to SN1 mechanism. We are going to look at the mechanism in future slides, but the 1 indicates the rate is only dependent on the halogen or alkane. So no matter what you do to concentration of the nucleophile, the rate doesn't go any faster or slower than what it is. Finally, if you're a secondary halogen alkane, you have a carbon that has only 1 hydrogen attached to it. It has the option to go both through SN1 or SN2. So if you are faced with a secondary halogen alkane and if they challenge you, then you probably can pick and choose your own sort of mechanism. However, SN2 is slightly slower because of the steric factor here. The nucleophile cannot make a back attack.